Welcome to Tech Brothers with Amir. In this video, we are going to learn about correlation function. What correlation function does, it calculates the correlation of two columns of a data frame as a double value. Currently, it only supports the Pearson correlation coefficient. So what we have to do, we have to provide such as data frame, then say correlation function, then column 1, that's a string type, and then column 2, that's also string type, and then method. In our case, as I said, that it only support a Pearson correlation coefficient, so there isn't really any need to provide any method here. Now these are the parameters, we have spoken about that. Let's talk about the Pearson correlation coefficient, often called Pearson measure, the linear relationship between two numerical variables. Pearson correlation coefficient values and the meaning, so that's table will tell you what exact it is. So if we are getting any value +1, that means a perfect positive correlation between, so both increases together. And if we are getting negative values, a perfect negative correlation, one increases, other decreases. And here you have no linear correlation. If no relationship, we are getting a value 0 here. So if you see right there, I have a sample data and I have name column here, then I have age column here, and then I have salary column. Now what we are doing here, we are creating a data frame, and in the data frame we are using the sample data and a list of the columns. Now we will go ahead and execute this piece of code, and then we'll be able to see the data in our data frame. So you can see right there we have name, age, and salary. Let's take a look on the age column and salary. So see right there we have a 25 age, and then we have a 50,000 salary. Then we go 30 and we have 60,000 salary, and then we go 45, the salary increases 120k, and then 35, the salary is 75. But you can see it is not in order by. If it would be in order by, so it is increasing with the age, that's the overall scenario here. And for 50, you are seeing that is $110,000. so there is a relationship when the age is increasing, the salary is increasing. Now if we run this into the here, say results equal to df and data frame dot correlation, and then we are given the two columns such as age and salary, is going to give us the correlation between age and salary. Let's take a look here. As both values are kind of increasing, if the age is increasing, the salary is increasing, so we should be getting some positive value. So let's see what we have here. Okay, still like, okay, let me run the entire thing. So here is our data frame, and that's the calculation. So as you can see right there, it is in the positive. Now that means if the one column is increasing, other one is also increasing. It's in the same kind of, they have the pattern going on here. So 25, 50, then 30. So it's a linear kind of relationship is there. Now let's change that. So if the age is 25, but salary is $150,000, and if age is 30, so salary is $160,000. So you see that we have two values. That doesn't really now, it's not with the age. The younger people are getting actually more salary than the older people. So if we run the correlation now between these two column, age and salary, you will get some negative number. So that tells you like the relationship is not it's not 100% like, oh, with the age the salaries are increasing. There is also the younger people have getting more salary, and you can make sense from looking at the correlation value from here, in which direction this whole calculation is going. Either is a relationship between age and salary is increasing in both in the same direction, or it's not. So in this case it's not, because the younger people are making more money and the older people are making less money. So thank you very much for watching this video. Please give a try and test out and see some other values that you would like to test by changing the values in your data, and I will see you guys in next video.